Example number 3. Given that cos alpha is negative 4 over 5, determine the other primary trigonometric ratios, and B, determine the possible values for alpha. Forgot to write something down. Between, or for, 0 less than or equal to alpha less than or equal to 360. So what's that? That's just asking an angle that's between 0 and 360. I just want to draw our attention to alpha. We've been using a lot of thetas. In fact, we even practiced pronouncing theta. Okay, what we're doing here is we're just using a different symbol just to represent a different angle, just so that you feel comfortable with it. Oftentimes in algebraic expressions, the textbook likes to try to use something like other things other than x and y, just so that we don't get too used to it. That's all that's happening here, okay? It's just instead of theta, which is a Greek symbol, we're using alpha, which is the first letter in the Greek alphabet. So this should look a little bit familiar. The only thing that's different with this one is that it could be anywhere, in any quadrant. Well, not any quadrant. Let's discover which ones, shall we? So we know that, I'm just going to let the cat out of the bag, the cast rule. Cosine is positive in this quadrant. All of them are positive in this quadrant. Sine is positive here, and tan is positive here. So we know that it's either going to be in quadrant 2 or quadrant 3. So this could be alpha, or this guy right here could be alpha. But what we need to first do, because remember guys, our calculators are dumb, we first need to figure out what our reference angle is. In this case, we're going to say alpha r instead of theta r, our reference angle. So we know from our previous like the intro video, that cos alpha is x over r. So that means that if our cosine is, if our x is, if we're looking at these two things, it means that our radius, I'm just going to make a nicer version of this. If we look at the reference angle, our radius is going to be 5, and our x value is going to be 4. Okay, something, if you're getting really into math, that's helpful to realize is Pythagorean triples. If I would use the Pythagorean theorem, I know that this guy right here is just going to be 3. Because 3 squared, 9, plus 4 squared, 16, is just 5 squared, 25. So since we solved for this, I mean, you could go through the whole rigmarole of, saying, c squared equals a squared plus b squared. But I just kind of did that in my head because I know Pythagorean triples. So what we can say is, yes, just kind of check. X is 4 and R is 5. Okay, so what about sine? So if cos alpha is negative, that means that we know that it has to be either in quadrant 2 or quadrant 3. So what's sine in quadrant 2 and quadrant 3? Well, sine could be either positive in quadrant 2 or in quadrant 3 it's negative. So the way that we discuss this, or the way that we denote this, is we just say positive or negative, and it's opposite, 3 over 5. Okay? Tan is the same story. It's going to be positive in quadrant 3, but negative in quadrant 4. So we would say tan alpha is positive or negative, opposite over adjacent, 3 over 4.
Ryan Silva, please report to the office.
So that's it for letter B. Let's talk, no. So that's it for letter A. Let's go on to B. Determine the possible values for alpha, for alpha that's between 0 and 360. We know that we're going to have two solutions where cos is negative. We're either going to have it in quadrant 2 or we're going to have it in quadrant 3. First things first, step 1, find alpha r, okay, or theta r, depending on what variable. So what I would do is I would say cos -1 of cos inverse of 4 over 5 is my reference angle. But when I punch that into my calculator, I know that I'm going to get alpha r equaling 37 degrees. So if my reference angle is 37 degrees, the quadrant 2 version would be 180 minus 37. So we would get an answer of 143 degrees. In quadrant 3, we have 180 plus 37, which is just going to equal 217 degrees. And we're done. Because cosine is negative in 2 quadrants, we're going to get 2 different answers. I hope everybody's seeing the value, the importance of finding out what our reference angle is first, and then using our knowledge of what's of the unit circle, or terminal arms, to make a decision on whether on which quadrants these guys live in.